Hi, everyone, and welcome to Olfaction Beyond Gravity, Human Scent Experience in Space. Before we get started with the actual lecture, just a couple things I would like to walk you through. This is a lecture in our Olfactory Research Notes series, an online series where we get sort of the important research directly from the scientists, researchers, and academics who do it. We are delighted to have Carolyn McMillan here today. By way of introduction, Dr. Carolyn McMillan is an olfactory researcher, artist, and technologist whose practice span installation, performance, and the body as a site of critique. Her work investigates sensory science, the aesthetics and ethics of human-machine interaction, and its societal and multi-species impacts. She currently leads innovation at the Space Sensory Lab of the World Taste and Smell Association, and you perhaps recently saw her at the Experimental Scent Summit in Athens. Um, for those of you for whom this is a new first-time experience, welcome to the Institute for Art and Olfaction. We don't have like a whole lot of rules and regulations, but we have this one thing called our Be Cool policy, and I'm just going to review that right now. Being cool means respecting the work of your peers, the agency of your instructors, and acknowledging the years of practice that inform our instructors' knowledge, which is why we're here today. Actions that are not cool include taking our instructors' materials and teaching them as your own, copying handouts without attribution, distributing videos, screenshots, or handouts without permission, or making hurtful or derailing comments in our chat rooms. We obviously welcome and encourage knowledge sharing, but our teachers should have a say in how their information is disseminated. As such, teaching material should not be shared beyond the class unless expressly permitted via email and credited to the teacher. We do not share our instructors' slideshows, but we will find a way for you to get in contact with Carolyn after the class. So let's hold off on that question, please. Now, in terms of recording, we are currently recording, and this video will be made available for you to watch for 14 days after the event has ended and this has gone to the cloud, blah, blah, blah. You can watch that video as many times as you want within that window. No extensions, please. And this is our new sort of sharing window, the 14 days. And last but not least, it's super exciting for us to have all these thoughts and questions. It is a little bit more organized for us if you drop your thoughts and questions in the chat, because Carolyn will be able to check them out after her presentation. So let's put thoughts, comments, and questions in the chat for the Q&A at the back end of class. And that's all from me. So take it away, Dr. McMillan.
Thank you, Minetta, and thank you to the broader team at the Institute of Art and Olfaction as Saskia and also Julia. And thank you so much for the invitation to bring Olfaction Beyond Gravity into the research notes lecture today. It's always a pleasure and an honour to be in this community, and I'm still feeling the glow from the Experimental Scent Summit a few weeks ago. Thank you all for joining from all the places you are in the world, especially, did I see someone in Australia? It's 3 a.m. That's really dedication. Thank you all for giving up your time to join the lecture today. So, Olfaction Beyond Gravity. In terrestrial architecture and design on Earth, olfactory cues bespeak identity, and they anchor our psychological well-being. But beyond Earth, astronauts carry out inevitable daily needs. They do it in confined, shared environments with minimal privacy, and their needs are oft marked by taboo or avoidance, even. And the circumstances of very hostile settings in life support machinery and built environments are characterised by sensory monotony, persistent odours, olfactory fatigue, and altered perception. So today I'll introduce research by the Space Sensory Lab. It draws on our work with the Space Sensory Lab, and this presentation especially explores how sensory design leverages olfaction as a really powerful dimension for high performance and space environments. So first I'm going to introduce the Space Sensory Lab, who we are, what we're about. Then I'll talk a bit about olfaction in microgravity. I'll talk about some of the sensory challenges, new frontiers for space design, then the smells of space, some extraordinary olfactory worlds, and finally sensory futures that centre experience, aesthetics and well-being, and the potential that lies beyond where design innovation intersects with science and psychology. And we'll have plenty of time for Q&A, so ask your burning space questions, ask them in the chat, save them to the end. So a little bit about the Space Sensory Lab. It's the R&D arm of the World Taste Smell Association, and is focused on human experience and well-being in microgravity and other extreme environments. It's an applied innovation agency. We're engaged to diagnose challenges, design sensory-driven solutions, and accelerate development in collaboration with astronauts, neuroscientists, sensory scientists, environmental psychologists, mission specialists, architects, hospitality operators, and more. This is a multidisciplinary endeavour. And at the Space Sensory Lab, we believe that designing for all the human senses is essential to the future of long-duration space flights and space habitation. So let me introduce our team of sensoronauts. There's Mindy Yang, who looks at human experience, sensory and clinical integration. You may know Mindy from the CEO of the World Taste and Smell Association. She's made incredible impact with that organisation and is a true global leader in sensory innovation. So Mindy translates science into experience-driven strategies, shapes future products, environments, and human connection on Earth and into space. She's long helped companies predict trends, build new categories, and optimize the human experience across food, beverage, wellness, fragrance, and hospitality. Then we have Colleen McLeod-Garner with Partnerships Food Beverage Innovation. So Colleen's a marketing, sales, and strategic brand developer in the commercial space realm and a Ph.D. in the making of human factors in space. Colleen combines business acumen with human-centered experiences to merge culinary craft, sensory science, and psychological wellness. And she's a top 100 women in aerospace and aviation. Jaren Chu. Jaren's a commercialization strategist and a new space advisor for space startups and scale-ups around the planet. She helps new space leadership teams become scalable commercial operations. She attends rocket launches with NASA and envisions the possibilities of humans living in space with delicious food and beverage experiences. And then myself, Caroline, I'm looking at sensory tech and innovation. And Minetta introduced me a little bit before, but yeah, I'm an interdisciplinary researcher more broadly of sensory systems, techniques, and technologies. I'm also a research fellow of the NeuroNext Odour to Action Network, the University of Hertfordshire's Biocomputation Research Group, the SENSE Research Network, and the ReFuture Lab. Olfaction in microgravity. So on Earth, air's the sculptor of olfactory space, and scent molecules, they disperse through rising air, through diffusion. For example, you can see in this image here, odour fluid dynamics from the Odour to Action Network. It's not something we see very often. Scent is often invisible. So here they're visualised using laser-induced fluorescence technique, and you can see that the odour plumes rise and diffuse in intricate ways. We see smell for the first time with this work. And then to do that, understand more about the spatial aspects of odorants to work with them. There's another image of the work. So smells travel by the movement of individual aroma molecules. However, without an atmosphere, there's no air pressure to carry odorant molecules. And in microgravity, the dynamics change dramatically. Without aggressive ventilation, warmer and cooler air accumulate in self-contained pockets. And with reduced airflow, the sculptor, which is the sculptor of olfactory space, odours can linger. They lie suspended. So what do you do when everything's floating, accumulating, collecting? Things don't stay put, they float away. And astronauts have to be super careful because it requires a lot more planning and specialized gear. And importantly, human smell sort of relies on two fundamental components: air pressure and moist tissue in the nose. And space is a near perfect vacuum, and it eliminates those fundamental components. So among the daily lived experience of astronauts is an account here by astronaut Clayton C. Anderson, who describes the powerful locker room scent that greets astronaut crew members. So to help avoid stink in space, I would hang everything post-exercise in front of one of the ISS, the International Space Station, the ISS air conditioning vents, assuming that everything would be fully dry before my next workout. That helped immensely. Contrast that with one of our crew who just stuffed his clothes up behind a hatch until pulling them out one day. Phew, I could smell him coming 2 modules away. So there's nowhere to escape these smells. And astronauts deal with stinky matters. Vomiting due to spaceflight adaptation syndrome, managing waste, and also menstruation. I'll just go back to here, the toilet, which is the breakout star of the recent Artemis 2 mission. The crew tested the first real lunar mission toilet and it broke 3 times. And on day 3, collected urine froze in the collection line, causing a blockage. The crew performed a controlled barbecue roll, rotating the Orion spacecraft to put the vent line and tank directly towards the sun, which partially solved the problem, but for a while the toilet was fecal use only. And it forced the crew to use backup urine collection bags. So a space toilet is trickier than you might think. And again, Clayton C. Anderson says, the lack of gravity means you rely on a suction fan system that requires many different parts. Sometimes they're shaken up during the launch. Then you have the freezing conditions, separation issues, chemical dosing fixtures, the list goes on. I can tell you from experience, that space is a magical, glamorous place until the toilet fails. In probably one of the most important pieces of equipment on board, the crew reported an odd burning smell coming from Orion's hygiene bay, which is a small bathroom compartment about the size of a small jet's toilet. And the smell reminded the crew of the odour of an electrical heater being turned on for the first time in a long while. So spacecrafts they have customized atmospheric ventilation and supply systems, such as these examples from Paragon Space Development. And they're systems designed to produce oxygen, filter air, mix gases, avoid stagnation, and accommodate temperature, humidity, and so forth. They trace contaminants, they detect smoke, and they recover post-fire atmospheres. So they're systems designed to revitalize atmospheres and their life support systems. With all these things going on, their space environments are recycled, ventilated, and they're hostile, and they're very closed environments of life support. And a spacecraft's not only a home for a while, it's also a machine and a very complex ecosystem where yesterday's coffee becomes today's coffee. So things are recycled. There's never truly fresh air or an open window. So now we move on to some of the sensory challenges of space. Gravity. The human body is used to experience gravity at all times. It's a universal experience of life on Earth. Have you ever thought about what happens to our bodies if gravity wasn't grounding us anymore? So what happens is fluids distribute through the body in a really delicate balance between gravity and the heart pumping blood. And for astronauts in space, Earth's gravity no longer pulls the blood and other fluids downwards towards the legs. The heart works hard to pump blood into the head. It's something like an extra 5 litres of fluid, or 1.5 gallons for the US folks. And so this shifting blood upwards in space collects more than usual in the areas closer to the heart, the torso, and the head. And it causes astronauts' legs to get thinner and their upper bodies and their heads to swell. And the bodily fluids evenly distribute. They center on the cranial and nasal cavity, congesting the nasal passages. So it's like hanging upside down for half an hour. And it creates a sensation or the phenomena of fluid movement within the body in microgravity that's known as puffy head bird legs. So it's a puffier head and thinner bird-like legs, a space odyssey, I should say. So in these unique conditions of space missions in microgravity, changes in the atmospheric pressure, motion sickness, changes in the bodily responses the astronauts are experiencing, it affects their physical, their physiological, sensory, emotional well-being. And one critical change is the muted perception of orthonasal aroma due to these changes of nasal congestion. And this shifts how astronauts perceive smell and taste. It affects their appetite, nutrition, and overall well-being on long-duration missions. So when we smell, we're perceiving the chemicals in the air that we breathe, and chemicals are constantly floating through the air. They have a material quality that allow us to perceive them as smells. And these chemicals, perceived as scents, they bind with the olfactory sensory neurons directly at the top of our nostrils. So with your finger up your nose, and I mean right up there, you probably just touch these sensory neurons. So the perceptible patterns for the scent of a rose or an orange or vanilla are all different, as are vomit or feces or the ick of space, the firing of neurons across the space of the firing of neurons, this sensory input for the olfactory bulb, and then the conscious perception of the amygdala, the limbic system. And that's where the perception of emotion, memory, and associations take place. And it's a direct co-produced neuroanatomy that's unique in our sensory system. It's a sensation produced and consciously experienced at once alongside emotion, memory, and association. And that's what affords smell its nuanced, emotional, memorial, and associative qualities. Smell is bodily, undoubtedly, it's bodily, but it's more than that. A sensation of smell filters all of our existence and our experiences. It's an environmental sense. It shapes our external world, how we perceive the environment. If we think back to the broken toilet, the star of the Artemis 2 mission, and it was detected through smell or change in the atmosphere. It influences our personal interactions, our cognition, our sense of self. It's deeply tied to emotional health, psychological health, familiarity, comfort, crew cohesion on board. And it has such emotional and evocative potency that scent grounds us with purpose and more specificity than other sensations. And on a mission to Mars, a meaningful scent could be the difference between distress and groundedness, a tool to calm, to focus, to center, to change a mental state. So having familiar aromas can seriously boost an astronaut's mood. It's a little piece of earth, a connection to home. And a question arises of how can we create meaningful olfactory experiences in orbit when our understanding of smell is profoundly altered, both physically and perceptually in microgravity. For astronauts or future lunar residents, food isn't just fuel, it's comfort. However, in a zero gravity environment, a cup of coffee could spell disaster. Food that produces crumbs pose a danger to a shuttle system getting into equipment. So bread can't be taken into space. Imagine this. After a long day of experiments and spacewalks, what's better than a meal that actually smells good? familiar foods can reduce stress. They can even make the whole mission feel more manageable. And in this scenario, psychological comfort's important as physical nourishment. After months of nutrient-paced or pre-packaged meals, getting a taste of pizza can feel like a piece of home. It breaks the monotony and makes a difference in how astronauts feel about their mission. While the challenges are real, the psychological win from a familiar taste can't be underestimated. So this image shows astronauts aboard the International Space Station with a pizza party, bringing a taste of home to orbit. And together they assemble and they eat pizza floating in microgravity. And they eat in small bites to control the floating pieces. Everything floats in a continuous free fall environment. Ingredients are secured with Velcro straps, stuck down with sauce and cheese to keep them from floating and drifting into the equipment. So for NASA and the European Space Agency, these shared meals boost morale in space. Pizza parties can also test the safety and handling of assembled foods in microgravity. And this matters for longer missions to the moon or Mars, where crew psychology and food variety are critical to mission success. Space as a frontier has a strong and distinctive whiff. The smell of space is not one simple smell. It's a cocktail of unique aromas. It's a chemical fingerprint from one of the most extreme environments humans have ever entered. This image here was captured by the James Webb Space Telescope. There's an orange protostar slightly right of the center of FS Tau B in the Taurus constellation. It's about 450 light years away. It's thought to be responsible for the red and orange, which are soot-like molecules known as polycyclic aromatic hydrocarbons, or PAHs, that we can see in the image. So the chemical contributors to PAHs are carbon-rich molecules, and they're composed of multiple fused aromatic rings. What's important about these is that they're compounds, they're ubiquitous throughout the universe, or what we know about the universe. And they're forming in the aftermath of stellar explosions, stardust, interstellar dust, nebulae. And closer to home, they're also found on Earth in soot, engine exhaust fumes, tobacco, incinerators, roasted meats, charred foods, and cereals, or when biomass burns at lower temperatures comparatively to the stars, such as forest fires. And our human noses are particularly sensitive to the deep space aromas of these small PAHs, the soot and other dusty materials stars form at the end of their life. So PAHs are the possible starting materials for the earliest forms of life on Earth, the seeds for life. Greg Jamitoff describes the smell of space. There's one smell up there that's really unique. We just call it the smell of space. There's this really, really strong metallic smell, and I don't know exactly what it is. But the true scent comes from these PAHs. They're energized by solar wind and cosmic radiation that clings to the objects returning from the void. So getting a sense of what space smells like emerges from the interaction with the spaceship and the spacesuits. The molecules that hitch a ride on the spacesuits, on exposed suits, gloves, and tools when they're brought back into breathable air inside the spacecraft. And these trace amounts are brought into the airlock. They create a noticeable aroma. This produces the unique sweet and metallic aroma called the smell of space. So for Nicole Stott, who's a retired astronaut, when astronauts come back into the space station for a spacewalk, there's a very distinctive sweet metallic smell, likened to a can of soup, or when opening the lid and the metal rubs against each other. So according to astronaut Chris Hadfield, the only time you can smell space is when you come back in from a spacewalk and you depressurize the airlock, open the hatch, a distinctive smell. It smells like being on a shooting range, a lingering gunpowder cordite smell, a bit like brimstone. So brimstone being a native sulfur. Others report ozone, sweet-smelling welding fumes, seared steak, a mixture between walnuts and brake pads of the motorbike. Astronaut Don Pettit describes this space station that smells like half machine shop, engine room, laboratory. And then when you're cooking dinner and you rip open a pouch of stew or something, you can smell a little roast beef. And to describe the smells of the moon, Pettit's theory is the desert rain effect. The moon's like a 4 billion year old desert. And when moon dust comes into contact with moist air in a lunar mobile, you get the desert rain effect, where molecules that have been trapped in dry soil are released and they produce smells previously hidden. Extraordinary olfactory worlds. So how can astronaut experiences inform sensory design? What if you're on a 6-month journey to Mars in a confined space with very few reminders of home? What sense would you bring back? What would bring you the most comfort? In Away from Earth, these questions were explored in an interactive scent installation developed by the Space Sensory Lab for the 41st Space Foundation Space Symposium Yuri's Night event in Colorado Springs. And Yuri's Night commemorates milestones in space exploration, such as Yuri's pioneering space flight as he flew the Vostok 1 spaceship on April the 12th, 1961. So here, Jaron and Colleen led nearly 100 space lovers, explorers. Just share the screen again. Just get a check, Minetta. Are we getting a full screen?
We don't have a full screen at the moment.
Okay, I'll just stop sharing and try again.
Turn it off and turn it on again. Yes.
Oh, I'm sure it happened.
Perfect.
Great. Thanks for your patience, everyone. It's disappeared in the extraordinary olfactory worlds. So Colleen and Jared were at the Space Symposium at Yuri's Night with space lovers, explorers, and astronauts around the world. They led them around the world through an olfactory activation designed by Linda Yang. Visitors sniffed ocean air, human presence, living soil, a walk in the forest, warm fire, and lunar ash. And these are scents astronauts report missing the longer they're away from home. Visitors were drawn to smells like a walk in the forest and living soil. These scents evoked memories of, even more memories than the memories of scents that were on display. So things like celebrating holidays, having tea with grandma, digging up the garden in preparation for spring. They were reminders of Earth and its grassy, wet, jasmine and petrichor tones, elements of woodland strolls. Visitors were also asked what other scents they want beyond the 6 prepared scents. And this is where elements of nature shined, with sandalwood, cedar, rain, plant, flowers, freshly cut grass, citrus, and even dog and wet concrete emerging over and over again. Away from home. What makes Earth feel like home when you're far from it? In this image are preferences for each of the scents. What sense would you bring with you on your journey to explore the universe? And this is where visitors shared more of the aromas that would tether them to Earth. We can see freshly cut grass, baby smell, husband, sandalwood, childhood, cheese curds, childhood memories, fried garlicky street food, vanilla and cookies, movie popcorn, winter snow scent, carnations, a new book, snow on the mountain. So what makes Earth feel like home when you're far from it? If you want to share your thoughts, you can use the QR code and you can take the poll and tell us what your preferences is. Also enter in the chat if you want to write something in the chat. Rain, chat. Yeah, I think rain is a very missable scent. Campfire for sure. Seaweed and mushrooms. Baked cookies, delicious. Flowers for sure. Driftwood and linen. Fire in the oven in winter, yes. Cozy, coffee, dog paws, yes. Pine, juniper, sage, and sand. Sarah, warm kitten fur. So many smells, but we can definitely see there are themes and things from the natural world. Something that we're all very connected to and tethered to. So from our senses, our whole universe blooms. And in the book Ways of Being, James Bridle argued that what we perceive, what our shared perception entangles, where our shared perceptions entangle with others, it forms an essential part of our Umwelt, which is a German word for a really distinct way that we sense the environment. And what we design for the sensory environment of space matters. Astronauts in microgravity conditions, they face issues such as altered, muted sensory perception. But what kind of setting are we actually trying to create? What should it make us feel? Heightened aesthetic experiences do change you. They change your biology, your mood, your emotion. And more recently with sensory design, fused with scientific research, it brings a deeper understanding of the interconnection of the body and the mind, the effect of, or affect of design and art and architecture, where it intersects with science to know more about well-being through sensory perception, through sensory design. And sensory design is the intentional orchestration of light, sound, taste, texture, movement. And these intentional spaces adapt according to user needs. They support mental health, a sense of comfort, emotional value, creativity, productivity, vibrant and balanced environments, to feel safe, comfortable, inspired, to reduce stress, to promote social interaction, increase concentration, or even contemplation. And neuroaesthetics play an important part in these spaces. And neuroaesthetics arise from the intersection between neuroscience and aesthetics, exploring how the brain reacts to experiences via research. It seeks to understand how perceptions affect our emotional well-being. But it also considers this psychological and physical impact on its users, often measured through neurotechnology and such ways of measuring experiences. And from these new models that arise, they're multidisciplinary approaches. They offer novel perspectives to understand and shape environments in ways they're conscious and they're responsive to our needs. So aesthetic experience is not just a matter of personal taste. It's really linked to cultural and geographical conditions and our brain biology. The composition of a space or object can evoke tranquility, joy, inspiration, the scent of the air, the colour of a wall, the intensity and type of lighting, the acoustics of a room. It's based on very specific scientific criteria about how these elements affect people's emotions and behaviour. So complete sensory experience creates more immersive, emotionally resonant spaces, objects, experiences. So it's not just about aesthetics, but it's about creating an environment that connects with us on an emotional level. And it can be achieved through very careful use of olfaction, which evokes very specific feelings, emotion, memory, and associations. And it can foster very deep connections. So looking beyond conventional approaches where an attention to detail for olfaction is a design dimension, specifically promotes health and well-being, these infrastructures have an embedded social logic that positions well-being as an ecology that includes the physical, the inner, and the communal aspects. So the future of high-performance environments are crafted with a sensory literacy. When we look at some of the earlier in the presentation, that very machine shop-like imagery is the reality of spacecraft. So when we start to think about how we can craft and bring in a sensory literacy to these spaces, knowing what the body needs and responding early, or even the ability to stop. So from these machine shop engine room laboratories to more sensory sanctuaries with intentional elements, choreographies of scent, taste, sound, light, texture, movement, ventilation, organic composition, hybrid structures, biophilic design. What if applications further explore the role of transdermal or inhalation or odour sequestering in future spaceflight innovation? Or multisensory amplification, buffering, resilience systems for spacecraft habitats, ones that incorporate sensory spatial infrastructures around building resilience and well-being, these cross-sensory input-output systems and perception-based trainings even. So the idea of enjoying familiar aromas among the stars isn't just a fun thought experiment. It's an invitation to push boundaries. Because what scent affords subtle, temporal, functional architectural layers that alleviate discomfort, they support mental health, and morale boosting shared rituals, like we can see with the pizza ritual. Very important for spaceflight environments and cohesion among the crew. It's a vital pillar in a well-being ecology that includes the physical, the inner, and the communal. So what might the future of space smell like? Thank you. And I invite any questions in the chat or otherwise. And if you want to chat more about sensory experience in space, get in touch. We'd love to stay connected. So the emails are here, or LinkedIn, or check us out online. Thank you.
Amazing. I'm going to scroll back up through our Q and A's. Kellen, you had a question about the Artemis 2 mission. Do you want to maybe read out your question, or ask it? You're more than free to unmute yourself.
Let's see. Test 1, 2.
All good?
Okay, great. Yeah, I was just wondering, this is commending your presentation, and I love that it's within the year of Artemis 2 mission. I have a little kid behind me, so
Great.
she might have a little something to say. But yeah, I heard somewhere, I can't remember what the source was, but it might have been a spectrometer reading saying that some of space smells like raspberries. Is there any research about like what the readings of space translates to our human perception?
Yeah, there's the raspberries one comes up, raspberries and rum sometimes often quoted as that. The NASA website does go into, they've got a section there where you can go and look there. And it is, again, about some of the compounds that are detected there, that they've been able to detect that smell like raspberries. So I guess that's why it's described as this sweet smelling burnt smell. I suppose the raspberries are adding the sweetness.
Thank you.
Thank you for your question.
Continuing with the questions that were in the chat, Erica has a question about, I'm going to round up and say pyrazines, but Erica, if you want to ask that question about scenting the air, please do.
Hi, thanks for having me. Yeah, I just had a question about the perfume in space and if it's been used before, and also just if that would be overwhelming, like you were talking about olfactory overload and things like that, and if you're sensory stimulated all the time by like all the awful sounding things that I never even thought of before, like the human body smells and things that you would find in space, is the more pleasant smelling things that you crave something you even really appreciate or want in reality because it might be overwhelming?
Yeah, I mean, it's a really good question. Thank you for your question. And I suppose the perception of smell is muted. However, I think what can be seen from the image back here is that fundamentally the materiality of everything changes in microgravity. So, and without a window to open, I mean, there are ventilation systems and they do their best to revitalize the atmosphere within the spacecraft. However, the reality is that things collect and they linger and they don't move around. They don't have the air to carry them as they may on Earth. So it's a bit of a paradigm shift to then all of many of the things we may have on Earth can't be taken up there in a way. So it's a really good question. I'm not quite sure how to answer that one particularly, but perhaps a good starting point is to really consider that anything liquid or liquid base is going to behave in this way. And it cannot be really, things are in tubes, or it needs a whole different set of consumer products as well to hold things in it also. So it has this knock-on effect of any kind of product or thing that you might use on it.
Yeah, would alcohol just explode anyway? If it had
Well,
an
it's
alcohol
flammable. And
yeah.
usually from Colleen, my colleague at Space Sensory Lab does a lot of work in this area. She would have been able to answer this question really well, but usually it's something, well, alcohol is, it's something that's not taken up into spaceflight.
No.
And Jolly,
thank you so much. And this has been incredible, your knowledge on this topic. And yeah, everyone's just cool people for being here. Thank you.
Thank you so much. Thanks for coming.
yeah, thank you, Erica. Anjali actually has a very relevant question pursuant to this about other disseminations of scent. Anjali, if you'd like to unmute yourself.
Hello, everyone. Can you hear me?
Yes.
Okay. Hi, I'm Anjali from Greater Seattle area, a perfumer with my own brand. I'm also a science fiction, a speculative fiction writer. My question was that perfumes do tend to stick to skin. Is this a problem of delivery mechanism of perfumes or scents? Might you have a roll-on that you put on your skin, and it could be wax-based or non-flammable base that someone could smell, or let's say a tube of material like a cream that might obviously float. I understand that it might go and stick to other like walls of the space, and that's probably not desirable. But so is skin a surface for perfumes?
Yeah, thank you so much for your question. The first thing that comes to mind is that also bathing or showering is very difficult. So it can involve wipes and so again, these processes are not as what we're used to on Terra, on Earth. So I think it's also thinking about buildup on skin.
Okay.
And I hope it answers the question. It just comes from a fundamental rethink of all kinds of products in a way. So you sort of have to rethink from the ground up what the conditions are and what can be there.
Okay. Thank you.
So it does require a rethinking of the kinds of applications. Maybe that's where things like transdermal techniques come in, contact with the skin. So it may require rethinking of the way we think about spraying on something, for example, if that answers the question.
I do have another, question regarding, when we eat food. Are you saying that there is a retronasal aspect of flavor? So when you're eating food and you're breathing in as you're eating, do they feel that aroma, or even that is muted? I mean, I'm sure it's muted, but do they get that aroma at least?
Yeah, it is muted, and that's the challenge. And the food in space is notoriously bland. I mean, it's packaged, and the nutrients don't necessarily survive the process of going up into space. So again, that's another challenge along with the olfaction, is the taste perception or flavorful food, food that people can feel interested about eating on an everyday. You don't want to eat protein bars every single meal, days on end, or packaged bars. So these issues would go together. It's not just thinking about olfaction in isolation, also thinking about taste and all the sensory aspects.
Thank you.
Thanks for your question.
Amazing. Chach, you have a question about visualizing scent dissemination. Do you want to ask it?
Yeah, wait, can you see me? No, you can't see me. Okay, there.
Hi, Jen.
Hi, this is a great talk. Thank you so much. Yeah, I got here a few minutes late, and so I saw the slides about the odor dynamics and that, there were lasers and it looked really, really cool. But I was wondering, like, one, like, how can we learn a little bit more about that? And then also, like, what kinds of circumstances does it have to be like a perfectly contained space that's like very dark and you vacuum out all the air and then put something in?
Yeah, thank you for your question, Judge. So this was a project from my postdoc with the Neuronex Odor to Action. You can just look up Neuronex Odor to Action
Okay.
website. They might have some information there. It was done by partners at Colorado University in the fluid dynamics. So we're looking at odor fluid dynamics specifically. What's really interesting about this, yes, very controlled conditions of darkness and all the things that you also need when you're working with a laser. Often with the laser, they need to be closed off as well. The odorant was dyed. So it was suspended in liquid and there was an odorant that was dyed. So, and then when it was dispersed into the fluid, the laser visualized it because it became visible in the laser. So what's interesting about this is it was possible to see the behavior of the odor plumes, because before then there may have been assumptions made, but it was all part of a greater endeavor to map odor. And it goes alongside other projects that were used with for inquiry into perception and odor, recording animal responses to odor plumes and their movements to determine things like cast and surge movement and the way animals detect an odor plume and move towards it. For example, I'll give you an example of the honeybee. I spent time in the honeybee lab there with partners investigating olfaction in bees, and they sense with their antenna. And yeah, there is an odor in space and this cast and surge movement that detect and then sort of move away and then move towards the odor plume again. So sort of moving in space, and if they're drifting, then they'll sort of go back into the path of the odor. So there were just ways to really map out the perception to action process. I could probably talk a lot more about it, but we can always do that offline one day.
Sure.
We can get into all the nerdy stuff, but definitely go to the Odor to Action website and you'll be able to see. I think it's really interesting just because there's a lot of speculation, of course, but when things are recorded and visualized in that way, there's no more speculation about what smell is doing in a spatial sense. So for those of us working with smell in a spatial sense, like in performance or in architecture, just got a better idea of what is happening.
Mm-hmm. And do they do that on, like, do they map like airflow in space, like modules, I guess? Like, and also do they have like an air filter that's like cleaning out all the molecules from the air? I'm just curious
Yeah,
about that too.
very, very good question. Again, Colleen, my colleague was working, she had very close contact with the ventilation systems that I put here, so that there are atmospheric ventilation systems to revitalize the atmospheres and address some of these things in these environments.
Yeah, so cool. Thank you.
Yeah, you can also go on the Paragon Space Development website and they have more information there if you want to look at a bit more granular information about some of the different methods they use.
Yeah, that's so interesting. Thank you.
Thanks, Judge.
Thank you, Judge. Just jumping in, Karen had a very related question about visualizing that molecular movement, and has that changed in space? Has it changed the way it's understood at all? Karen, perhaps you can also sort of rephrase that question. I'm not copied right now.
No problem. Yeah, I mean, I think it's piggybacking, and maybe whether it makes sense to kind of continue that, but I'm mostly like interested in the visualization. Do you feel like it's been understood differently in any way? Um,
Yeah, this is an interesting question. Thank you for it. They're two separate. So the visualization was happening in my postdoc, and it's not connected to commercial space in that way. So I can't answer to how it's measured in commercial space. I mean, it's a very good question, but I know that this laser-induced fluorescence technique was unique to the lab at Colorado.
Hey, Colorado. Yeah, because I feel like when I've looked into visualizations of scent before, it largely feels like it's based on molecular structure, whereas this is on kind of like effervescence, airflow. Has that as a data visualization yielded any different kind of understanding, or do you feel like it's mostly, yeah, kind of movement of movement of notes and kind of degree of movement?
Yeah, it's a really good question. And I would say beyond the scope for those particular experiments, those particular experiments had a different aim, but one can speculate from this, and as an aromatherapist myself, and also doing some perfumery, when you're mixing things together, my questions started to become, I had more questions. How are two scents relating together in these atmospheres? What happens? Do they join? Are they dancing together? And so I think it creates more questions, and there would be a lot more scope for further research in this area of visualization. I think it only inspires more questions. And how is it working in a bigger space as well? This is very controlled conditions, lab conditions. How might it work in a big performance venue, for example? What would it take to fill a big performance venue? What kind of diffusers would you need? And so I think that there's a lot, the clues are there in this work to think about how scent can be used spatially. Thanks for your question.
And the last of our written questions, Evan has a question. Evans, if you want to ask it, if you're still
Yeah, I'm
here.
jumping in there.
Excellent.
I know we're talking about like the external kind of smells that are injected into the space. um, Backing up a little bit and talking about the human interaction, which is, we are scent bombs in our own space. Um, is there any kind of special process that I know that they're, to my understanding, they're sequestered before they go up and they're integrated with each other for such a long time. Their skin biome is obviously integrated, hopefully, and it's not too repulsive. Is there any kind of special process that they go through or to prepare for that? Have they addressed that at all? Does that make
In terms
sense?
of the astronauts for the crew and
Yes, yes.
the skin biome, was it?
Yeah. I mean, or is there any special process that they go through to reduce their odor profile, for lack of a better term?
Yeah, it's a really good question. Thank you. Again, Jaron and Colleen, my space co-founders, would do a very job of answering that question. I wonder as well as in even things like actors or the theatre, there is quite a specific regime about you must turn up clean, teeth brushed, and things like that. As a designer, I imagine that there, or would hope there might be some kind of criteria for going up. Possibly because you're in close quarters. I mean, this opens up a big area because when we look at this kind of situation as well, I mean, there are all sorts of stinky matters, exposed stinky matters, whether it's humans or the toilet or other things. And there, of course, were measures by the quotes that we had there by the astronaut. There were measures taken by some maybe thoughtful crew who might air out their garments in the AC units, but some not. So again, that comes back to the social factors of smell, right? And heightened in this very confined environment. I think it only brings up more really good questions about is there a criteria or a protocol, or is it more about conventions and manners and all sorts of things? What do you think? What do you think might be a good protocol?
I don't know. It's just, I was just trying to visualize just the emotional reality of sharing food together in space and just that communal emotional tie-in that they would all have for community, and then reinterpreting that with our body smells and how that integrates, and just like our physical processing of certain spices, and it just I don't know, it just shifts it just a little bit, because we are our own little perfume scent bombs ourselves.
Yes, scent bombs.
So,
And a lot of it is taboo as well, right? I mean, we're talking here about food and things, but then there's waste and menstruation and all sorts of bodily matters that happen and are ongoing, their daily needs and requirements in this small space. And that also opens up more issues, because particularly female astronauts choose not to menstruate on mission for various reasons. So I think it runs very deep, this question.
I'm
And it's a
sorry,
good one.
I just want to back up just for a second. Choose not to menstruate. As someone without that mechanics, how does someone choose not to menstruate?
There would be birth control that would skip the cycle.
Got it. Wow. It simplifies things, but sounds strange.
Yeah. And I suppose all these taboo things as well. If you're in very close quarters, you don't necessarily always have rooms to go off. We might be very close together. So it may not be preferable to sit in between two male astronauts. And yeah, so it's a really, really interesting question. And there's meal sharing and cleaning rituals and all sorts of things.
Okay.
The
Thank you.
stinky matters, the bodily matters of space.
Thank you for addressing.
Thank you very much for your question. Great questions.
I think we have no more questions, but maybe a little bit of time for two spur of the moment questions. Please feel free to unmute yourself, or I guess you could also raise your hand, but I feel like we are all very well behaved today.
Can I just start talking?
Yes.
Please.
Hi, this is Miriam.
Hi,
Hi,
Miriam.
hi, how are you?
Good. How are you?
I'm good, thank you. I have a question that's not so much about the scent, but about the non-scent. So the ventilation systems in these spacecrafts, it sounds like they have limited ventilation. I mean, even planes have limited ventilation, but I'm wondering, are they working on increasing that so that the quote fresh air supply would be better, or is it just not a doable thing given the way space works? Because I don't have a clue.
It's a really, really, really good question. And if you do go onto the Paragon Space Company website and they've got their ventilation, that answers quite a lot, because it does go into detail about what they're filtering or recycling, more detail than this slide can do here.
Good. Okay.
So yeah, it's a really good question, and more of the technical information is going to be there answered in a better way than I can tell you. But I just imagine as well these, I mean, they can be very stagnant air environment, and odors sort of collect or linger, and just these very simple normal moments like opening a window and getting movable air just doesn't exist. So again, it's one of these things where the foundational baseline is so different that things have to be rethought from that ground up.
Mm-hmm. Yeah, that makes sense. Sounds sort of super gross.
Yeah, it does, doesn't it? And not being able to shower or not being able to clean yourself very well. And it sounds like quite an endurance mission, that's for sure.
Yeah. Well, I
Thanks,
have
Mary.
the website up. I'll take a look. Thank you so much.
Yeah, thank you. Thank you. Anyone else have some burning space questions?
Don't be shy. Now is the time.
Now is the time. You can always, if you think of something later, you can always contact one of us and
maybe I wanna like what I figured out now in my perspective, in my sense, like perspective, I always want to like individualize myself with scent and stand out, but it looks like in space it's the opposite. You wanna like not so stand out and bring more scent into this small space, and maybe like being have all the same scent experiences, like everyone sharing the same scent experiences and not standing out. It's like creating community. It's maybe more important than individualize yourself.
Yeah, Eva, hello. Nice to see you. And thank you so much for your question. And I think that's a really important point, because the cohesion of the crew is very important. If there are risks to someone not coping very well, it can be a danger to a mission in these kind of environments, really critical. And yeah, and maybe from some of the things we've talked about, there's a certain level of comfort for social reasons, let's say. Yeah, it's a really good question. However, I think there's always going to be a want or a need for some individualized preferences if there is any carefree time, particularly for longer duration missions. I think without that, I think that would be a reason for stress as well, to not have that way to come back to yourself as well, to be always thinking of the communal. So personalized solutions, I think, are very necessary. Yeah, thank you, Eva. Very interesting thing to think about.
All very interesting things.
Chat just talking about cozy sleeping bags, like scented sleeping bags.
Yeah, I watched so much of the Artemis footage, and so I feel like I went on the journey with them. And yeah, they would be like such a team the whole day, but then they would go to sleep in their like sleeping bag in like different positions, and I can imagine like that might be a nice time to have like a quick descent.
Yes. Yeah, scented sleeping bags.
I think we are at time, so I want to thank everyone for sharing their time and their questions and their enthusiasm with us. And I especially want to thank Dr. Carolyn McMillan for taking time out of her day to let us know all about space. And I'm sure we'll have more questions. And thank you for sharing your email with us because I'm sure I'll think of 1,000 questions as soon as we sign off. But we are going to sign off. So you'll receive access to this recording in a couple hours, and then you'll have that for 14 days. So we hope to see you again. And once again, thank you so much. Bye, everyone.
Thank you.
Thank you. Bye.
Thank you very much.